LeetCode problem number 72, edit distance. So this problem gives us two strings, word1 and word2, and the goal is to return the minimum number of operations required to convert the string word1 to word2. So here it gives us three operations. We can either insert a character, delete a character, or replace a character. Right. So here it gives us an example as well. We have a horse, and to convert the word or the string horse to ROS, we will replace the first character H with an R, and then remove the extra R, right? So it will be horse, remove the replace the H with the R, and remove this extra R, and as well this extra E, and we will get ROS, which is word 2. So my approach to this problem is to use dynamic programming again. So the way I do it, okay, so let's say I have a graph for starters. I'm not sure what this is doing here, but yes, let's say I have a graph. So not really a graph, but a 2D matrix of basically this 2D matrix will store the minimum number of operations for those characters, right? For each character in the string. So let's say the word 1 is ABC, word 2 is ABC, I guess, right? So obviously we know that we will only need to replace this character to get the word 1 into word 2. But let's see how it works in the code, right? So again, I mentioned there's a 2D vector, right? So word 1 size, so there's three of this, right? And for each one inside, there will be 3 as well, right? So for starters, I will make them 0, I guess. Okay, so it looks something like this. So just to write it out, or since it's plus 1, there will be a extra 1. So this will look something like this. We have A, B, C, and this is just an empty string. And on the top here, we will have A, B, C, and then the base case, right? This will be the base case. Okay, so we populate the base case. So for in I equals 1, as long as I is less than word size, we are replacing the first character of each into I, right? So I 1, so 0, 1, 1, 0, this character will be 1, right? Will be I. So this one and this one, right? Okay, next we do the same thing but for the y-axis. So for this first one, it will be 1, 2, and 3. Okay, so these are the base case, meaning if we were to convert, this is ADC, if we were to convert, let's say, if we were to, okay, so basically on this box, should be like this. Yep. Okay, so if you were to start from here and convert it into an empty string, right? From string ABC, we will need to have 3 operations which is to delete 3 characters, right? A, B, C. Right. Same thing if we were to do it for two characters in a word, we will need to remove 2 characters, and vice versa for the y-axis as well. Okay, after that, we go to our for loop. So this for loop will iterate through every single character against the characters in word 2, right? So what will happen is, if the current word we're looking at, so let's have the pointers out first. So I equals to 1, right? So we are technically looking at I minus 1. So 1 is at B, right? Minus 1 is A. And here we have J. Let me put the number in. So J would be 1 as well. Alright, so now we check, since both of these string, the first character of which is the same, so we will just copy the result we got from I minus 1 and J minus 1, right? So I1 J1 is at this box, so minus 1 will be at this box, right? So this will remain as 0. Next, J will increment to D, and since they are not the same, so here we check dpi dpij will equals to equals to 1. So I again is here, however J is here, so we're looking at this character now. So it will be equals to 1 plus the minimum of minus 1, and minus 1 is 2, minimum of 2, this minus J minus 1 is 0, and minus 1, which is 1 itself. So the minimum would be 0, so this will give us 1. Okay, J increments again, so we're looking at this character now. Again, since they don't match, so we do the same thing here. It will be 1 plus the minimum of 3, 1, and 2. So obviously the minimum is 1, so it will be 1 plus 1 give us 2. Okay, I increments, now we're looking at B, J goes back to A. They are not the same, so we do the same thing. 1 plus the minimum of 2, 1 or 0. Minimum is of course 0, so 1 plus 0 will still become 1. Same thing here. B, they are not the same, so we do the same thing. 1 plus minimum of 1, 0, 1. So obviously this is going to be 0, which is 1. 1 plus minimum of 2, 1, and 1, right? This is obviously 1. 1 plus 1 is 2. Okay, next, I will increment once more. J go back to A. We repeat the same process. They are not the same, so we add up the minimum of the 3 previous cache results. This will be the minimum of 1 plus minimum of 3, 2, 1. This is 1. 1 plus 1 is 2. Increment D, 1 plus minimum of 1 of 2, 1, and 1. This is 1, so we get 1 plus 1 is 2. And lastly, since they are the same, so again, if they are the same, we just copy from this value here, which is 1. Okay, now once that is done, so we look through for our DP, what we have calculated. We have deduced that the minimum number of operations required to convert ABC to ADC, of course, would be to just replace it. And it says so over here as well. The final result with 1, where DP, if you were to access 3, right, since above 3, it will be 1, right? We return 1, which is proven here as well. Okay, so yeah, that's basically how the code works by running dynamic programming. That's all I have to show. Thanks.